Michael is designing the roof of a house. The width of the roof is 6.1 meters. The roof will be in the shape of a right angled triangle of height h, where h is an element of or. Michael can choose different values for h. The diagram below shows one possible design for the roof, not the scale. Calculate the slant height, x meters, of the roof of this diagram. Correct the two decimal places. Okay, whenever you see a right angle triangle, you should think about two things. It's going to be either sine cos tan, or it's going to be Pythagoras theorem. In this case, we're working with two lengths, and our answer will also be a length. So we're working with only length. That gives us confirmation that this will be Pythagoras theorem. So we're going to have to use a squared plus b squared is equal to c squared. So let's just fill it in. 6.1 squared plus 2.84 squared will be equal to c squared. So the square root of 6.1 squared plus 2.84 squared will be equal to c. So if we do that on the calculator, that will give us an answer of 6.73 meters. Correct the two decimal places. So this would be this was actually 6.7287. So because we have an 8 here, we'll round up. So we wanted our answer correct to two decimal places. Okay. For part B, the diagram below shows a different design for this part of the roof. Use trigonometry to work out the size of the angle marked theta in the diagram. Give your answer in degrees, correct the nearest degree. So as we were saying before, we want to think of either sine cos tan or Pythagoras. In this case, we're working with two sides on an angle, therefore our brain should automatically go to sine cos tan. So here we will be working with the opposite angle and the adjacent one. So that means that we will be using tan. How do we write that out? So the way I like to remember it is sa, ka, and toa. Sa, ka, toa. And then by saying opposite and adjacent, I see that it's here. So it's going to be tan of theta, so we don't know what it is equal to opposite, which is 3.12, over adjacent, which is 6.1. Now, we won't be able to solve for theta like this. We might think, oh, you just have to divide both sides by tan. But in trigonometry, it doesn't work by that. We'll have to switch the places of theta and the fraction that we have and use tan inverse. So tan inverse allows you to switch those places around. So like this, where 6.1 is equal to theta now. And now to get theta, all I have to do is just use my calculator and fill what we have written on the page in. So that will give us correct the nearest degree, 27 degrees. So make sure to try this on a calculator and make sure that you know where to get all of the buttons. So tan minus 1 on a Casio calculator is done by pressing shift and then tan. Okay, let's have a look at the next part. A different part of the roof is in the shape of an isosceles triangle. So as soon as we see stuff like that, isosceles triangles, we want to think, okay, two equal sides, two equal angles, with base 14 meters. So we see that in the diagram there. In this part of the roof, Michael makes an attic room by putting the two vertical side walls, AB and DC, shown in the diagram below, not to scale. So the distance from B to C is 8 meters. So 4 meters from either side. The total height of the roof is y meters, and AB is equal to DC. So that seems, so AB is equal to DC, which is equal to X, and then we're just all the numbers are real numbers. That seems like a whole lot of information. So it's all sort of thrown at us. So we want to take it all bit by bit. We don't want to get overwhelmed. We have all the information that we need in the diagram. Let's now have a look at the question. So we want to use similar triangles to show that X is equal to 3y over 7. Okay, so similar triangles to show that X is equal to 3y over 7. Okay, so we want to draw this triangle out. So this will be x. And then we want to extend this one here. This will be our bigger. So y. And then, so I'm just looking at the left half of the triangle. Up to here, this will be 4. Then from here to here, it will be 3. And we know that this entire distance is 7. So how did I get that? This is right the middle point. So of this, it's going to be 7 here and 4 here. So remember that this is 8. So 8.5 will be 4. And then this here will be 3. So what I can say is the relationship between x and 3 is the same as the relationship between y and 7. So what I'm saying is right side over bottom is equal to right side over bottom. So we're using those similar triangles. So we know that these are similar triangles. So I'm using AB and this point here and E to the bottom and this point here. So just sort of help you visualize A, E, and B. So I'm saying the right side to the bottom and the right side to the bottom for both of the triangles. That relationship is equal because with that fraction we're describing the ratio, we're describing the relationship. Then to show this, all I have to do is just multiply both sides by 3. If I multiply both sides by 3, I will get x is equal to 3y over 7. Now, this might seem like a completely random equation that we're given at the start. And you might think, how can we prove that? What you want to do is find the similar triangles, so like we have here, and then what I did was just wrote out the relationship in some way. Even if you did 3 over x is equal to 7 over y, you'd get there eventually to get to that answer. You just have to move stuff around. So it's just a case of trying stuff out and trying to get to that equation that they want you to get. Okay, so that's part 1 done. The area of the shaded region ABCDE in the diagram is 12 meters squared. Using your answer from part C, part 1, or otherwise work out the value of y. So looking at this one, the easiest thing to do seems to be getting the area of this rectangle here and then getting the area of the triangle up top later. So first, let's focus on the rectangle. So the rectangle would just be length by width, which will be 8 by 3y over 7, or 8 by x, but remember x is now equal to 3y over 7, so we can use that. And that will be 24y over 7. So that will be the area of the rectangle. So now we want to look at the area of the triangle up top here. So that will be, our base will be 8. So remember, the formula for the area of a triangle is half the base by the perpendicular height. The base by the perpendicular height, which will be half. The base will be 8. So getting that from here, it's the same sort of as the length of the rectangle. And then the height, that will be y minus x. So it'll be the difference between y and x. So it's all of y taken out the x. So it'll be y minus 3y over 7. So half by 8, that would just be 4 by y minus 3y over 7. And then let's just multiply that out. So that would be 4y minus 12y over 7. So now if we add this area, so this is the area of the triangle. So if we add the area of the rectangle and the area of the triangle, they should both equal together to 12. So let's just do that now. So we'll say the rectangle is 24y over 7 plus 4y minus 12y over 7 is equal to 12. Now we just have to solve this. So first I'm going to do 24 minus 12y, so that will just leave me with 12y over 7 plus 4y is equal to 12. Then I'm going to try and get rid of this fraction that we have here. So we'll do multiply everything by 7, so 12y plus 28y is equal to 12 by 7, which is 84. So 12y plus 28y, that will be 40y is equal to 84. So is equal to 84. Then we just divide both sides by 40. And y will be, so 84 divided by 40, y will be 2.1 meters. Which if you think about the height of a roof, makes sense, and that will be our answer.